Hi everyone. Today I'm going to present a paper entitled Blockchain Solutions for Big Data Challenges, a literature review. Overall, this paper summarizes good examples on utilizing blockchain from different domains and perspectives. Though there are few mistakes presented in this paper, it still be a good handbook to refer to some typical blockchain solutions for big data. As we all know, the blockchain has been seen as a revolutionary solution concerning the data decentralization, trust, identity, and data ownership. Meanwhile, this new trend, excessive data expansion, has been taking place in quality and diversity of the digital data. Thus, the blockchain can be provided as a significant input to seek the best way to store, organize, and process big data, for its proposed decentralized management of data may have significant impact on the big data involvement. This paper presents several novel solutions associated in 4 big data areas that can be empowered by the blockchain technology. And blockchain, which is a peer-to-peer decentralization public ledger that contains all the transactions that executed in the system, and it requires no centralized authority to manage the blockchain database, and there is no longer a mediator processing the actions and the data. So which will result in 3 major factors. 1, it will be lower transaction costs. And 2, it will be non-reversible transactions. And 3, it will be no need for trust the government or private corporations. And usually, the transactions of the blockchain are validated and authorized through a predefined consensus protocol, or sometimes we call that smart contract. And the traditional blockchain's consensus protocol, including the rules such as always choosing the longer chain and the specific hash requirements, for example, like starting with certain number of zeros. And on the other hand, there is a role called miner, which is very important in blockchain technology, which are responsible for creating new blocks on new dataset or transactions by completing a predefined computational task, for example, the proof of work. And the new chain will with a newly added block will be broadcast to all other miners, and each miner will validate the new chain according to the consensus protocol and compare with its local chain. If the new chain pass all the validations, the local chain will be replaced. And this paper stated that only the new block will be broadcasted. However, based on the current blockchain technology, the new chain instead will be broadcasted, which can result in multiple versions of the chain out there at the same time. And but overall, they will be maybe they will converge to one of the new and longest chain in a later stage. So in this way, a malicious node needs to have more computational power than all the other miners in order to alter any historic data and generate longer chain of the blocks from the touched one, and in a faster speed than all the other miners. And the ledger of the blockchain remains anonymous for all the users by using the public key as the address, and using the blockchain transactions, the user can store and direct exchange the asset that they own. So in the following, this paper presents 4 possible blockchain solutions that can be changed the current model to collect and control massive amounts of data. The first solution is in the personal data. As we know, the concern of the losing control of privacy is currently deteriorating as a social network are consistently collecting users' personal data, for example, like your actions, your habits, your favorites. And in the mobile apps, concerning the inability for user to revoke the granted access to his or her private data, which are usually being granted when you install the app or when you first time use the app, the only way usually to revoke the permission is by uninstalling the app. And Zinsky and other and others proposed a solution on mobile apps based on the blockchain technology for access control on private data. Users will be able to control, audit, and revoke which data are stored and how they are being used. And this solution is composed of three entities. One is a user, one is a service provider, and other is a blockchain. As its blockchain supports two types of transactions. One is a transaction of access, and the other is transaction for data. And besides, it introduces a shared key which combines the user's public key and the service public key. So it will be used to encrypting the data in the blockchain. So it also leverages the DHT, which is also called distributed hash table, to store all encrypted data in a centralized manner. Because the data is encrypted by the shared key, any adversary control on the DHT cannot compromise the privacy of the sensitive data. And this paper states that the distributed storage is also decentralized. However, that is not necessarily true. Here the DHT is more likely to be a centralized solution, but it's distributed manner. Another research on user-controlled social media is UShare, which envisions that users should be able to track the posts they share, as well as they may control the upper bound of the number of resharings. UShare also leverage a centralized way, DHT, to store the encrypted documents, image, and videos, and the blockchain only have the hash key of the encrypted data, which acts like a hyperlink. And above two examples both utilize a decentralized blockchain to save the key or the link of the data and use a centralized method to save the large data set. And on another very specific implementation of blockchain in the area is a big data in the digital property. Though there are many artists, designers, and creative workers can share easily on the internet of the work, but keeping the rights of the property has proven difficult in the digital world, and there is no transparent way to specify the ownership, as the files can be easily copied or fully replicated with no signs of the original. For example, a failure case on the internet called Ascribe has a crucial flaw regarding the ownership questions, and once a work is put online or even sold out online, the author loses complete control, and there is no visibility of what is original and what is copied after duplication online. So that is an issue. And at the same time, though there is some bidirectional reference approach has been introduced, for example, like the Zalando has been tried to resolve the author's attribute issue, but it's more than complicated and not feasible for wide usage. Now the blockchain has been introduced into the Ascribe, which tries to address the digital property registry and feasibility of the copies. So they also try to find out all the existing copies of protected contents. For example, if you have already applied for a patent or apply for a copyright of your work, they will help you to find out all the existing copies online by crawling the entire internet with similarity check. However, this approach may have issues on those digital properties which are stored in the private networks. And here is a diagram for above solution. The ownership data are kept in the blockchain to remain trustfully, truthful, and irreversible. And other documents associated to the product can be stored in a document database such as MongoDB or CouchDB. For the art portfolio, which can be stored in a file server such as on the Amazon Simple Storage service, the ecosystem would find a way to link the blockchain, the document repository, and the digital art storage together. On the other hand, Monograph is another example to build new modern and user-friendly digital marketplace based on the blockchain technology, which helps the artists and owners to claim the rights and commercial values of their digital media. On the other hand, the Bitmark step further to allow the transfer of both digital and physical objects. For the physical objects, they introduce a new solution which called Object Minity, which is a framework for identification of the physical assets based on the unique surface level texture patterns. So in this way, every asset in the Bitmark registry will firstly get recorded with its fingerprints, metadata, and registered signature, and the new Bitmark is also created when the asset is set to a new owner. And then the Bitmark ownership can be changed by an ownership transaction in the blockchain. And thirdly, in the world of Internet of Things, using traditional technology to build IoT system with diverse protocols turn to be complicated and sometimes with conflicted configurations, which usually relies on the centralized server client paradigm. So in such system, all the devices are identified or authenticated and connected through a cloud server. Even if the solution works fine for now, but it maybe have problem if we have a larger IoT ecosystem in the future. How IoT devices work now is that they're going to be controlled by the user from a centralized place or point, for example from a user's mobile device. So in this way, all the actions, commands, and rules are set by the user. While this is a good for personal control, but it's not automated in many ways. So in order to achieve an automated and secure manner, in a vision of one IBM's report, the blockchain is proposed to facilitate transactions and coordinations among the device. Each device will own its role and manage its behavior in the internet in a decentralized and autonomous things, Internet of Things, and such that the real revolution can happen if the device get controlled by the blockchain instead of the user. So this is possible by leveraging, for example, like the smart contracts. On the other hand, the Slug.it is a first implementation of IoT and blockchain using the Ethereum platform. This is the so-called slugs are the real-world physical objects that can be controlled by the blockchain, which makes it possible to rent the access to any compatible smart object. So the use case can, for example, like in Airbnb apartment, sharing bikes, sharing cars, etc. In this case, when a customer rents a service for a specific period of time, a digital key or authentication to the apartment door or to the bike locker or the car will be automatically granted to the customer through blockchain, and that can be accessible through a mobile app. On the other hand, the Dory and others propose a secure, private, and lightweight smart home IoT solution based on the blockchain technology, which acts on a local network and contains all the smart home objects and a local computer as a local miner. In this way, using the blockchain, the IoT transaction towards into a network of devices that can interact with each other according to the blockchain's rule without any human intervention, so that you don't have human to specify what it's going to do and all the things that will be predefined in a blockchain. So it's like absolute loyal housemate that can help you to manage all your smart device. Doesn't it sound perfect? I think that's good, right? And the fourth area is in the healthcare. As we all know, the big data in healthcare system comes from a variety of sources, such as clinical trials, electric records, patient database, etc. So overall, healthcare data has to be accessed or assessed and interpreted in a timely manner to benefit the patients. Consistently, healthcare staffs are also seeking the new tools to track or trace and provide the fast feedbacks for individual patients in a highly secure manner. For example, like the healthcare data should be conformed with a HIPAA regulation to protect the sensitive patient healthcare information. And a blockchain does not rely on one centralized storage facility. This can be helpful for the government and other enterprise to be liberated from the liability of data. And furthermore, as owners of data, the patient will be empowered to decide who they will share their data with. For example, the healthcare data will be oriented more to the patient, so they have the right to decide which hospital can see their data or which group of the healthcare provider can see the data. But still, it will be an imbalance with other important players in the healthcare system, for example, like the doctor, hospital, and insurance company. And on the other hand, the Gupta and others explained how blockchain would enable the interoperable and secure electronic healthcare data storage or exchange. They also claim the patient ultimate owner of their healthcare data, and only the metadata will be stored in the blockchain. So in this work, the patient sign the transaction with his or her key. When he goes into a new hospital, he must provide his key in order to read the blockchain transactions. Only the stakeholder who has his key can decrypt the transaction and see the data. As the data saved in an anonymous format or manner in a universal healthcare cloud, it provides or it has a very good base for query, mining, or statistical analysis and machine learning on the healthcare data, so which is a big problem at this moment. Another case study is about MedRec for the blockchain healthcare, which utilize the Ethereum's smart contract to create a representative of existing medical records. So these contracts, as we know, are stored directly in the individual's nodes in the network or in the Ethereum network. So in the MedRec, the mining reward or the mining incentive is some approved access to the aggregate anonymous medical data that is for example, like the research or the medical analysis, something like that. So after reviewing all four aspects of the review in this paper, here comes to the conclusion. This paper presents a blockchain many promising trend of big data in which the blockchain can be leveraged as secure authentication mechanism or a predefined smart contract for mediating data access and data manipulation in different areas. Though some challenges still remains, for example, like computational costs of mining blocks and validating transactions are extremely high. Such continuous improvements in the data in the blockchain technology are reflecting it might be still in an early stage of development. And also it's opening a new and revolutionary path for many exciting possibilities and wait us to explore. So that's pretty much for the presentation today, and thank you very much for your time and attention. Until next time, happy coding.